Hi guys, welcome to the lesson. This is Text and Test 6, Chapter 3.8, page 122, 123. We are looking at, products and quotients of complex numbers here. So this is tied into the idea geometrically that if you take a complex number and multiply it by another complex number, if you remember, multiplying by I always caused a 90-degree anti-clockwise rotation. Multiplying one complex number by another causes a rotation and an extension of the modulus, and we'll see how here. The rule is given here on page 121. If Z1 is this complex number in polar form and Z2 is this one, then the product of those two complex numbers is the product of the modulus, and then you add the arguments. So multiply the modulus, add the arguments. When you're multiplying, when you're dividing, you divide the modulus and subtract the arguments. Now you can see here the proof, it's all tied up in some trigonometry that we haven't done yet, so don't worry too much about that proof. We're just going to use this. Some of the questions might use this idea here as well, that if Z is r cos theta plus I sin theta, so if that's it in polar form, 1 over Z is 1 over r times cos of the negative of the argument. Okay, so 1 over the modulus and the negative of the argument. But this here, these two rules here, are the primary ones we're going to be working with. So question 4 on page 122 asks us to multiply these two numbers together. So following our rule, multiply the arguments. 4 by 3 is 12. Multiply the modulus. 4 by 3 is 12. Add the argument, so that's going to be cos of pi over 6 plus pi over 3 plus I sine, again add the arguments, pi over 6 plus pi over 3. So that is going to be 12 cos, well that's 2 pi over 6. So that's 3 pi over 6 when you put it together. 3 pi over 6 plus I sine 3 pi over 6. And we get ourselves 12 cos pi over 2 plus I sine pi over 2. There's our answer. So you can see your modulus has been extended and your argument, you've had a rotation in the argument. Okay, the size of the extension depends on the modulus of what you're multiplying by, and the size of the rotation depends on the argument of what you're multiplying by. Here, question 5 asks us to divide. So again, the rule says divide the modulus, subtract the argument. So this is 9 over 6 times cos 5 pi over 6 minus pi over 3 plus I sine 5 pi over 6 minus pi over 3. Okay, and pi over 3 is same as 2 pi over 6. That's 2 pi over 6, so that becomes 1.5 cos 3 pi over 6 plus I sine 3 pi over 6. So 1.5 or 3 over 2 maybe, cos pi over 2 plus I sine pi over 2. Okay, there's the answer to question 5. And then we're going to have a look at question 8, which asks us to simplify this expression here. Okay, this is kind of foreshadowing a thing called de Moivre's theorem. You can see it there. It's the next topic we're going to look at. I'll just show you quickly how to do 8 part A. So it asks you to simplify 2 cos pi over 3 plus I sine pi over 3 cubed. Okay, and this depends on the idea that the cubed operator is distributive over multiplication. So that is 2 multiplied by this. So we can say that's the same as 2 cubed times cos pi over 3 plus I sine pi over 3 cubed. Now, that's 8, that's fine. This bit here, if you remember, if you're multiplying, and this is just multiplying by itself 3 times, you add the argument. So this is kind of like cos pi over 3 plus I sine pi over 3 multiplied by cos pi over 3 plus I sine pi over 3 multiplied by cos pi over 3 plus I sine pi over 3. The same thing 3 times. So you just add the 3 arguments that you'd have. So that's going to be cos of pi over 3 plus pi over 3 plus pi over 3 plus I sine. Hopefully you're happy enough for me to just multiply that by 3. And that's going to be just pi. Pi over 3 multiplied by 3 is pi. So we get 8 cos pi plus I sine pi. There's 8a. I'm not going to do 8b. I am going to have a look at, I think, question 10. The last one we said. Question 10, which asks us to express this number here in polar form and hence express z squared and z cubed in both polar and Cartesian form. So z in Cartesian form, or what I called rectangular form earlier, is minus 2 plus 2 root 3 I. Okay, so we want to express that in polar form. Always a good idea to start with an Argand diagram, even if it's just a little bit of a sketch. Minus 2 plus 2 root 3 I. It's going to be up here somewhere. There's minus 2 and there's 2 root 3 I. The modulus of that number is the square root of 2 squared plus 2 root 3 squared, which is 4 plus 4 root 3 is 12. So the modulus is 4. The reference angle is the inverse tan of, that's 2 root 3 over 2 of the inverse tan of root 3 is going to be 60 degrees. So what we're going to get is, that is the reference angle of 60. The argument then is 180 minus 60, 120 degrees. So the argument here is 180 minus tan inverse 2 root 3 over 2. Again, always take the positive, and that comes out as 120 degrees. So in polar form, z is 4 cos 120 plus I sine 120. What question 10 said, express it in polar form, hence express z squared. So z squared is going to be this times itself. So multiply the arguments, that's 4 by 4 is 16. Multiply the modulus. 4 by 4 is 16. Add the arguments, that's going to be cos 120 plus 120 is 240. Plus I sine, again add the arguments, 120 plus 120 is 240. So there's z squared. Z cubed, well, is z squared multiplied by z. So again, multiply the arguments. The modulus, this seems to be a recurring theme, 16 times 4. Sorry about that. 16 times 4 is going to be 64. Add the arguments, so that's 120 plus 240. That's cos 360 plus I sine 360. By our definition of cos and sine, when you get around to 360, you start again. So that's just 64 cos 0 plus I sine 0. It's the same as 360. There it is in polar form. They wanted in polar and Cartesian form. Well, let's see this one. Now do we have space? I'll do this one first. 64 times cos of 0 is 1 plus I sine of 0 is 0. So the answer there is 64 in Cartesian form. For this one, z squared is 16 times cos of 240 is minus 0.5 plus I sine of 240 is, now it's minus root 3 over 2 is what we have there. Minus root 3 over 2. You can look that up in the log tables to get the surd version, or I think the newer Casio calculators will change it into a surd for you. So multiplying through there, that's going to be minus 8 plus 8 root 3 I. Okay, so there's 10 in, there's z in polar form, z squared in polar form, z squared in Cartesian form, z cubed in polar form, and z cubed in Cartesian form. So in class tomorrow, please, page 122, 123, we're going to look at questions 1, 2, 3, 6, 7, and 12. Okay, thank you.